This is Engage New York, Module 2, Lesson 8. This is Concept Development. Going back to our objective for today, I can fluently multiply multi-digit whole numbers using the standard algorithm and using estimation. So, standard algorithm and estimation. So let's first look at our first number, 314 times 206. So let's go ahead and round each factor to its closest, closest 100, I guess. So 314 would definitely round to 300. And 236 would round to 200. Now, second, I can multiply the factors. 300 times 200 would be what? 6. 2 times 3 is 6, and then I'd have 4 zeros. 1, 2, 3, 4. So rounding just lets me think, okay, well, this right here, I should know when I use standard algorithm, my product or my answer should be about $60,000. But remember, it's going to be a little bit higher than 60,000 because remember, we rounded down. We didn't round up. So what if I asked you to express that as with an exponent? So remember this word, exponent. So what if I said, well, what does that look like in an exponent, friends? Well, it looks like 6 times 10 to the 1, 2, 3, 4. It's 6 times 10 to the 4th. That would be expressing it as an exponent. Make sure you remember this. All right, so now our actual answer, our actual product is going to be, what do you think? I'm just going to ask to see if you were paying attention. Do you think our actual product would be less than 60,000 or greater than 60,000? So, well, let's go ahead. I think you guys are absolutely correct. I think it's going to be higher because we did round down. So our true answer, our true product is going to be higher. So now I simply do standard algorithm. So see how we just reasoned why we think our true standard the product is going to be higher. We just reasoned, and our reasoning was that we rounded down in order to get our 60,000. So because we rounded down, we know our actual answer is going to be higher. So that is that reasoning, that reasonableness that I'm looking for. Can you tell me why? So go ahead and let's solve this. And if you don't have to, but I like to do these in different colors as I solve. 4 times 6 is 24. 6 times 1 plus 2 is 8. 6 times 3 is 18. Now I'm going to switch colors. 0. 3 times 4 is 12. 3 times 1 is 3 plus 1 is 4. 3 times 3 is 9. Now 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Now we're going to add it up. Here we go. 4, 10, that's 12, 13. Wait, here's 16 and 4 is 20 plus 1 is 21. Here's 9. There's 10 and 2. 2 twos is 14. 74,104. Does our answer make sense? Well, we did a good job with our multiplication, and we did say that our true product is going to be more than 60,000 because we rounded down. So let's just write it. We knew our actual product would be greater than our estimated product. Now here's the kicker, because we rounded down and multiplied. Okay, this right here, this is the crux of the entire lesson. Can you state why? I know you could round. I know you can do standard algorithm, but can you put the two together? Can you reason why you came up with your answers? That's the big idea for today. All right, moving on to problem 2. So let's go through the same steps we just did. So first, we're going to round. So who can tell me what we're going to round our numbers to? Because we rounded up, our actual answer is going to be, our actual product is going to be less. So let's go ahead and do our estimation. 2 times 3 is 6. And I'm going to have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. So our estimated answer, estimated product, is 600,000. Now, let's go through and do the actual standard algorithm to see if it's going to be less than or greater than. And then over to the side, you are going to write okay, so let's go through it. Can you guys do the standard algorithm without me? Or do you need me to do the standard algorithm for you? So what I want you to do is I want you to go through and do the actual standard algorithm, and then I want you to come back and check to see if your answer matches mine. All right, so we did standard algorithm. 557,072 is less than 600,000, and that's what we predicted. We know our actual product would be less than our estimated product because we rounded up and multiplied. This has to be on your paper. If it's not correct. All right, last problem, and then we're going on to problem set. 4,902. What should we round that number to? And what should we round 408 to? Can someone help me? So definitely we would round 4,902 to 5,000 and 408 to 400. Now, the question is, when we round, how is that going to affect our actual answer? So will this be close to it or farther apart from it? That's what we need to think about as we go through this problem. So 5 times 4 is 20. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 2 million. So now let's go through and solve. But geez, I wonder, we rounded this one up and we rounded this one down. But we rounded this one up by 100 and we only rounded this one down by 8. So I wonder if it's going to be greater than 2 million or less than 2 million. That is the question. All right, so go ahead and solve. Let's do it right now. 4,902 multiplied by 408. That means you have 408 copies of 4,902. You have 408 copies of that. So go through and solve and then come back and check your work. Don't forget to write down what your estimate, what your prediction is. So you're writing this down. we knew our actual product would be greater than our estimate because, don't forget to write the because we rounded up by 100 on one number and rounded down by only 8 units. That's why. It's because we rounded up a whole 100 but rounded down by 8 units. So we knew our actual answer would be greater than our estimate. So our actual product is greater than our estimated product because we rounded up by a whole 1,000 and we rounded down. Okay, so now we're going to move on to problem set. So make sure to keep this handy because remember, you use your notes that you take in class with your problem set and with your homework. All right, problem set. You are going to start out by rounding the two numbers just like we did. Then you're going to do the actual algorithm, the standard algorithm. On the back, it says each container holds 1 liter and 275 milliliters of water. So a full liter. So think of one of those water bottles and 275 milliliters of water. So 1.275. How much water is in 609 identical containers? So if you had this and you had 609 of them, how much water would be in there? Then find the difference between your estimated product and the precise product. So go ahead and round. So step 1 is to round your numbers and do an estimation. Step 2 is to do standard algorithm. Problem 3, a club had some money to purchase new chairs. After buying 355 chairs at, almost $200 each, there was $1,068 remaining. How much money did the club have at first? So you're going to have to work backwards on this problem. Number 4, so far, Carmela has collected 14 boxes of baseball cards. There are 315 cards in each box. So 14 boxes, 315 in each box. Carmela estimates that she has about 3,000 cards. So she buys 6 albums that holds 500 cards each. Number 1, will the albums have enough space for all of her cards? So when it says why or why not, you need to write it will or will not because. How many does she actually have? And how many albums will she need for all of her baseball cards? So you're going to estimate and you're going to do the actual and then decide whether she has enough albums to fill all of her baseball cards. All right, so go ahead and get started and we'll come back and debrief in just a few minutes.